Okay, let's go ahead and get started. First things first, like I said, back here to our web page. Like I said, I did want to, here's our Canvas page right here, and I will, I guess you guys can see it a little bit better. There you go. Wanted to point out one thing. We do have finally got our classroom for our Friday review sessions and stuff. And that is Fretwell 121, a nice big classroom that I can combine both you two guys at one time. So, obviously you know when our class is, Tuesday, Thursday. For our class it's 2 to 3:15. But I do have our, what we call the recitation section. It is on Friday, every Friday from 3:30 until 4:45. So, and it's in Fretwell 121. And that is when we will sit there and mostly focus on answering questions and doing web work problems and stuff, and making sure you're acclimated to how to understand web work, how to get these problems just right. Because remember, it's a computer, so typing this stuff into a computer can be difficult. I mean, you got the right answer, but how in the world do I relate that information to the computer so it gives me credit for it? Things like that, because that's always been a tough deal. Like I said, so we have that set up for us Friday, and Katrina, sitting there in the back just grinning to no end, is going to be leading the review session, her and Sarah, on most days, except for the days that I'm going to either have to make up snow days. Hopefully it'll snow sometime around here. And the other times, obviously, when just before we have tests, we'll have a review set, homework set due, and I will take over the class on Fridays then, and I'll make it due then, and I'll actually record that for everybody, post it for everybody, so you have something to study over the weekends and stuff like that. So there we go. All right, so let's pick up where we left off, which was we were working in section 1.3. Okay, let me see if I can fix this again. Let's see, full screen. No, they actually messed it up. All right, let me see what I can do about fixing this thing here. It's not, yeah, they didn't actually do me any good here. Let's see here. See if I can imitate display settings here. Advanced.
Right below apply.
Right below apply.
It's like towards the center. Yeah, to the right.
To the right.
Down like 2 boxes.
Oh, right here, landscape.
Underneath apply, click advanced.
Oh, I'm sorry, underneath it. There you go. Let's see what we get here. We'll go back to this thing here, and then we will keep changes. See if that do anything. And now if I did this, okay, great. And now full screen. And I'm back to the way it was, but at least you can see the darn thing, so that's better. All right, they're gonna have to work on this. All right, so, but nevertheless, obviously what I was talking to the people before about the computer thing was the border around the screen. You know, that's great. I mean, but we don't need a picture of all the wonderful stuff I do. I want to make it bigger than life for you guys. So I want them to get rid of the border so I can make it even bigger for you when I'm recording this stuff. Most computers do this, but of course ours, this is a new setup we have in here. So they've got some recommended settings, and that's not what I want recommended. I want to try to get rid of that. Hopefully by next class we'll have this thing taken care of. All right. Remember last time? We were working on limits. Let me blow this thing up so you guys can see this thing. We were working on limits. First rule of limits. Plug in a number, get a number, I'm done. You know, because what the idea behind a limit is very simply this. You've got a function, and you're trying to figure out what's going on at a particular point. 5. Well, if 5's a problem point, then we're going to have to do some manipulation to it. But if 5 is not a problem point and I want to figure out what's going on at 5, I'm going to take the limit as x approaches 5 with some function. And first rule is plug in a number. If I get a number, there was no problem, that'll be my limit. However, when we did these problems down here, one of our big problems is the ability to divide by 0. So if I've got a function, I'm going to check it out by first rule is plug in a number. But if I got 0 over 0, that's called indeterminate form. Because the question is it going to cancel? Or is it not exist because you can't divide by 0? Or is the answer 0 because the numerator is 0? Well, I can give you examples of all three different cases. That's why it's called indeterminate. But the first rule of indeterminate forms is if I got 0 over 0, do algebra on the thing, if you can, and hopefully something will cancel. So I did these two problems for you last time, just to remind you as we're getting set up for the day here. This problem here, I took the limit as x approaches 4 of x minus 4 over x squared minus 16. Obviously, we plugged in 4, and we got 0 over 0. And then I decided, okay, 0 over 0, we're going to do algebra. But remember, it's not about just getting the right answer, but how I wrote it up. So this is equal to the limit as x approaches 4 of x minus 4 divided by, and x squared minus 16 factors in x plus 4, x minus 4, and the x minus 4's cancel. So this would be equal to the limit as x approaches 4 of the resultant 1 over x plus 4. And then I plug in the number 4, and I get 1 over 4 plus 4. Notice I didn't write limit anymore, and I get 1/8. So it's about how I wrote it up, but the answer is 1/8. And then over here, I did the exact same thing. I took the limit as x approaches 3 of x squared minus 3x divided by x squared minus 2x minus 3. I plugged in the number, and I got 0 over 0. And that tells me maybe I could do some algebra. I could see that I can factor out an x out of the numerator, and the denominator factored into x minus 3 times x plus 1. The x minus 3's cancel, so that would be equal to, and remember, as you're doing algebra, you keep writing the word limit, 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 up until the point when you plug in a number. So the resultant would be, after you clean it up, is x over x plus 1. So this is the limit as x approaches 3 of x over x plus 1. I plug in 3, and I get 3/4 for the answer. Okay? But here's my problem. Sometimes I can't do algebra, okay? If I can do algebra, that 0 over 0 hopefully will cancel. But not everything is going to allow me to do that. So turn page. Okay. Now, hopefully, and again, your homework for tonight was to do this. Let me go back over here and pull up my modules, my Canvas page here. And we go over here to modules. You were supposed to, now I know this is still drop add period, so nothing closed out on you yet, but it's going to. So if you go over here to where we're at. Now last time we talked about what you were supposed to do before class, you got to come to class, and what you got to do after class. Before class, you were supposed to have already watched the pre-section video on section 1.3 and taken the quiz. We are in class now. We're going to finish up the notes on section 1.3, and then you got homework. This is WW, web work for section 1.3. You got problems to do on that. You got about a week to do them and so. And then you're supposed to go ahead and start section 1.4. Watch the pre-section video on that. Take the quiz on section 1.4. Come to class, get the notes off of it, and then after we finish with our lecture on that, then you've got web work homework to do for that, web work 1.4. And you go, well, how do I know what sections I'm going to cover on any given day? Well, if you go up here to the top, you know, you got the course documents up here, and you'll notice that under course documents you have the famous 1241 Tuesday, Thursday schedule. If I click on this thing here, and you can either download it if you want to, but if you come up here and look, you'll see today's Thursday, 1/11. We're supposed to be covering sections 1.3 and 1.4. So you know what we're going to do. Now this is obviously a tentative schedule as we go through the semester, but it kind of gives you an idea of what I'm going to cover and when I'm going to cover it, so what you're expected to do. So because these quizzes after drop add are going to close out on you the day that I start covering that material. I may not finish it, but if I start covering that material, you are supposed to have the pre-section work done for that material, so you have a clue of what's going on and stuff like that. So to give you guys an idea of how the redesign is actually set up and stuff. So, all right. So let me go back over here to this thing here. All right. So hopefully you'll watch the awesome pre-section video some professor did for you. And we did this problem right here. So I got one that just looks just like it. I'm going to talk about him since I did this one on the video. You're actually supposed to take notes off the video in your notes here. So here it is right here. Let's take a look at this guy. I want you guys to take the limit as x approaches 0 of the sine of x divided by x. Now, first rule of limit, so I'm going to write it up here in the margins here. When I take the limit as x approaches 0 of the sine of x over x, first rule of limit is plug in a number. That would be the sine of 0 divided by 0. What's the sine of 0? Things we got to know from trig class, high school, 10th grade stuff here. What's the sine of 0? That's 0 divided by 0. And there it is, 0 divided by 0. Which means, quote unquote, I'm supposed to do algebra. So this would be equal to the limit as x approaches 0 of the sine of x over x. What kind of algebra are you going to do on this thing? What can you do? Does anything cancel? The goal is to cancel this stuff. What cancels? Well, clearly the x's cancel. So when I do that, and I end up getting the limit as x approaches 0 of sine, because the x completely cancels there, and then I plug in 0, but there's nothing to plug in because there's no more x's, and what do I get? No. What is sin? That's not sine anymore. That's a trig function with sine, but if sin without an angle, you know what you got? Sin, what does that spell? Sin, and that is what you've committed if you do this kind of crap in terms of algebra. You can't get rid of an angle on a trig function. You got trig function divided by a polynomial, x. And so you can't cancel this kind of stuff. Trig functions have an angle and they can't be touched. They're going to be set in stone there. The angle on sine is x. What you've got here is I've got trig divided by a polynomial. And they're not like terms. There's no canceling to be done. That's my point. There's no algebra you can do on this thing. You can't always do algebra to clean something up to cancel some other. When you can, please do that. But if you can't, we got to do this method here. As I mentioned to you guys last time about this idea of one-sided limits. So up here, I'm going to take the limit as x approaches 0 from below of the sine of x divided by x. And over here, I'm going to take the limit as x approaches 0 from above of the sine of x over x. I'm going to take the limit as x approaches 0 from both sides, from the negative side and from the positive side of 0. And if the limit exists, they'll go to the same number. So this is really a calculator problem here. Now, before we even start using calculators in here, this is trig functions. What mode should my brain as well as my calculator be in if I'm doing trig? Radians. So check your mode. Math, there it is. Radians, right up there, already been highlighted. Okay? So, back this thing off a little bit. So the first thing I'm going to do is I'm going to plug in x is negative 0.01. So this would be, let's show you what I'm doing here, the sine of negative 0.01, negative 0.1 divided by negative 0.1. So the sine of, plugging in for x, negative 0.1 divided by negative 0.1, and what do I get? I get 0.998334 or something or other, okay? I got close to 0. Now I'm going to get even close to 0. Now we're going from below, slightly below 0. That's why these numbers are negative. Negative 0.1, negative 0.01, negative 0.001. So now I'm going to do the sine of negative 0.01 divided by negative 0.01. What do I get? I get 0.999833334 something or other. Okay? And if I plug in, take the sine of negative 0.001 divided by negative 0.001, I end up getting 0.9999. How many nines do I have here? I got 3, 6 nines. 4, 5, 6 nines, 8, 3, 3. So here's the question. This is where you have to use your analytical abilities. As the x numbers approach 0 from below, from the negative side, what is the functional values? What's the functions approaching? What number? 0.9. Oh, look, I got 0.2. When I plugged in 0.1, I got 0.29s. When I plugged in negative 0.01, I got 0.49s. When I plug in negative 0.001, I got 0.69s. What's this thing going towards as you get closer and closer to 0? 1. 0.9999991. Does that make sense? Now, let's take the limit as x approaches 0 from above. So now we're on the positive side. So, plugging in 0.1, this would be the sine of 0.1 divided by 0.1. And you notice, you got the number 0.9983341, whatever. Now when I plug in the sine of 0.01 divided by 0.01, I end up getting 0.999983333. And then when I plug in the sine of 0.001 divided by 0.001, I end up getting 0.99999, once again 6 times 83333. So once again, as this approaches 0 from the plus side, my functional value is approaching 1. Now, the best way for me to describe you the definition of a limit, the definition of a limit is this. When I take the limit as x approaches a particular number from below and from above, the functional values from below and above have to go to the same number. If they go to two different numbers, the limit does not exist. If they go to the same number, that's what the limit exists, and it's equal to that particular number. Since we both went to 1, I can say therefore, 3 dots in a triangular fashion is therefore in mathematics, the limit as x approaches 0 of the sine of x divided by x is actually equal to 1. The limit exists and equals 1. But here's the problem. The only way I could show you this is by the traditional way of actually doing what we call the T-bar, basically plugging in numbers into my function and seeing what it's going towards. So we got to be clear. When we start doing these limit kind of problems, I got to know when do I need to do a T-bar and when do I not need to do a T-bar. Because let me tell you, every problem that you have as a limit, you can be done as a T-bar. But we would not allow that. There's only certain kind of problems we want to see the T-bar. This is one of them. What made this one so special that I actually had to do the T-bar? There was no algebra I could have done. If you go back and look at the problems we did before, these two problems, still 0 to 0, I could have done the T-bar on them, made a little T-bar and get close to 4 from below and get close to 4 from above, and let's see what the numbers approach. And they both would have approached 1/8, and so that would have meant the answer would have been 1/8 and stuff. The problem with that is we don't want to see T-bar stuff with these kind of problems. Why? Because you could do algebra on this thing. The only time we want you guys to use a T-bar is when you can't do algebra. Does that make sense? If there's algebra to be done, you got to do the algebra and show us the algebra part of canceling and all that good stuff. All right, let's keep going here. Graphing. I want to give you guys a visual perspective of this thing here. So, this one right here. We want to take the limit as x approaches 0 of the sine of x over x, and we want to use it from a graphing perspective. So I'm going to do that. Go y equals, clear out the old stuff I have in here. And remember, I'm still in radian mode. The sine of x, close parentheses on the angle, divided by x. And I do a zoom 6 on this thing. And that's what you see. Well, it's a trig function. You're expected to see some waving on this thing. So I'm going to do the zoom in feature, zoom in on my calculator, right there at the origin. So I'll kind of blow it up so you guys can see what's going on. You should see a graph that looks just like this. But the problem with this thing is you're actually not seeing exactly what's going on. Let me show you what I'm talking about here. What really is going on is this. We're trying to take the limit as x approaches 0. 0 is right there at the x-axis, and we want to know where the functional value is going towards. It's going right up there. But the problem is, right up there, what's really going on, you've got the y-axis slapped right down the middle of this guy, so you actually can't see it. So what I'm going to do here is I'm going to go to Format, Second Format, just for this example, and I'm going to turn my axis off and graph it. So it graphs the function without actually showing you the axis. And what do you see? Let's see if I can get the zoom feature on this thing working. So if I zoom in on this thing, there is a pixel that didn't get lit. Exactly, and it's not because my calculator's broke. Nope, there's a hole in the graph. That's exactly what's going on with this thing. Okay, but if you couldn't have seen it, you would not have seen it if I did not turn the axis off. Does that make sense? So, from a graphing perspective, let me kind of pull this thing back and actually go back on my calculator and turn the format, turn the axis on, because you'll be frustrated with me from evermore if I don't turn it back on. If I go into this problem, when you look at this problem, this is what's going on. When you graph it, as you get very, very close to 0, there was a hole in the graph, and then it came back down and did this. Here is 0, and the coordinate is up here at 1, okay? And so there's a hole in the graph, but as I take the limit as x approaches 0 from below and from above, you'll notice that both sides are going towards the y coordinate 1, the limit is 1. That's the visual perspective of what's going on. Does that make sense? Questions? What about this one? What is the limit as x approaches 0 of 1 over x? Well, let's graph that sucker 1 over x. Y equals, clear it out, 1 divided by x. Zoom 6. Well, there's my graph. I'll go ahead and graph it. You've no doubt have seen this function before. It looks like this. We call this a hyperbola. Okay? Here is your y-axis, here is your x-axis, and here is 0. And what are we supposed to do with this problem? Let me blow it up. You guys can see it in the back there. We're supposed to take the limit as x approaches 0 on the plus side, on the right side, of 1 over x. So this is not a two-sided. This is not a full limit like we had earlier. This was a full limit because we don't have a number a plus or minus behind the number, so I had to go from both sides. But this was a one-sided limit. Okay. So as I approach 0 from above, where's my functional value? What is it going toward? Where's my function going? Well, as I approach 0, you're going to basically get 1 over 0. Now, 1 over 0 is not the same thing as 0 divided by 0. What is 1 divided by 0? Undefined. And undefined, we typically write DNE. Does not exist. Okay? Now, we're going to come back to this particular concept when I get you guys into chapter 1.6. And we're going to be looking at the idea of infinity answers. And so right now, in chapter 1.3, a number divided by 0 does not exist, and that's how we're working. The answers in the back of the book are going to be coded. The answer doesn't exist. But I'm going to go ahead and give you guys some insight of what we're going to do in chapter 1.6. 1.6, we're going to go back and start allowing to have infinity answers. Now this, guys, you get very, very close to 0. On the positive side, this thing's going to get higher and higher and bigger and bigger and bigger and bigger and bigger. It's going to positive infinity. And when I get you to chapter 1.6, we would say the answer is infinity. Okay? Does not exist. But right now, we're just going to say, hey, can't divide by 0, doesn't exist. We're going to go back when I get you 1.6 and redefine the concept of infinity for answers and stuff. Okay? So be prepared for that. But for right now, I can't divide by 0, doesn't exist. Now, some more examples. Here we go. Gave you a graph. We're trying to give this visual perspective on this stuff. F of A. Okay? Here is A right there. What is F of A? Where's it equal to? Well, it's L. Here's the difference between, and what is the limit as x approaches a of f of x? What is that? That's also L. What's the difference between the two? F of a is asking you right at A, where is the dot located at? It's located at L. When I ask you what is the limit as x approaches a of f of x, that means as you get very, very close to A from below, and you plot it, and you get very, very close to A from above, and you plot it, what number are you approaching? And are you approaching the exact same number? As you approach, both numbers are going towards L, so that is equal to L. Does that make sense? Subtle difference here. Now we got this function. We called him g of x. What is g of a? Nope, not L. You know why? There's no dot there. This was f of a was L because there's a dot. We plotted the point, and the y-coordinate of the point is L. What is g of a? Does not exist. There's no hole. There's no dot there. There's a hole in the graph. You got to have a dot. Where's the point plotted at? There is no point being plotted here. Does that make sense? However, answer this question. What is the limit as x approaches a of g of x? As you get very, very close to A from below, plot it out, see where the y-coordinates are going. As you get very, very close to A from above, plot it out and tell me where the y-coordinates are going. And you're going towards the same y-coordinate, and what is that y-coordinate? L. So the limit as x approaches A of g of x is L. However, g of A does not exist. There's no functional value at A. Does that make sense? Questions? Subtle difference between functional values and limits. Limits is what's happening as I get very close to, and functional values what's happening right there at the point. And the right at the point doesn't exist, but the limit is L. So let's do this problem. So I've given you a piecewise function. F of x is equal to 7 minus x if x is less than or equal to negative 4. X if x is between negative 4 and less than or equal to 2. And x minus 1 squared if x is greater than 2. Here's my questions. What is the limit as x approaches negative 4 from below of f of x? What does this mean? This means I'm getting very, very close to negative 4, slightly less than negative 4. Since we're dealing with a piecewise function, I got 3 pieces of my piecewise function. I will denote them as top, medium, and bottom. As x approaches negative 4 from below, we're slightly less than negative 4. Which piece of my piecewise function do I get to use? Top, medium, or bottom? Top one. Because here I use 7 minus x, the top one, but when x is less than or equal to negative 4. We are less than negative 4 when we do limits because of that little minus sign behind it. We're slightly less than negative 4. So this would be equal to the limit as x approaches negative 4 of 7 minus x from below. Okay? But so you have to, when you're doing these piecewise functions to do limits, first you got to figure out which piece you need, and then the second thing, evaluate the limit. First rule of limits is to do what? Plug it in. So this would be equal to, and once I plug it in, I don't write limit anymore, this would be 7 minus x is going towards negative 4. And what's 7 minus negative 4? A minus makes it plus. 7 plus 4 is 11. The answer is 11. And if I get a number, I'm done. That's the answer. Does that make sense? But now, let's do this one. What is the limit as x approaches negative 4 from the plus side, or from the right? So, now I'm slightly bigger than negative 4. Which piece of my piecewise function do I get to use? Top, medium, or bottom? Medium, because when x is between negative 4 and less than or equal to 2, greater than negative 4 and less than 2, I use this guy. When you take the limit as x approaches 4 from the plus side, that means you're slightly bigger than negative 4. Slightly bigger than negative 4, I use the guy in the middle. So this would be equal to the limit as x approaches negative 4 from the plus side. Your function is x. And of course, first rule limits to evaluate it is plug in the number. The answer is negative 4. Does that make sense? Got another question for you. What's the limit as x approaches -4 of f of x? You notice they did not put plus or minus here, so we're talking about the full limit. For the full limit to exist, the limit from below has to be equal to the limit from above. In this problem, the limit as x approaches -4 of f of x from below was 11. So you're down here. The limit as x approaches -4 from above, from the positive 5, is -4. It's down here. They're not going to the same thing. So what is the answer for what's the limit as x approaches -4 of f of x? Does not exist. Does that make sense? Well, let's do another one. What is the limit as x approaches 2 from below of f of x? Okay? 2 from below. That means I'm just slightly less than 2. Which piece of my piecewise function do I get to plug into if I'm slightly less than 2 for x? One in the middle. Less than 2, I use the middle. So this would be equal to the limit as x approaches 2 from the left, from below, of x. And the first rule of limits is plug in a number. You get 2. X is going to 2 of x. You just plug in x, it's 2, and you get 2. Now, take the limit as x approaches 2 from the right. That means you're slightly bigger than 2. Which piece of my piecewise function do I get to plug into? Top, medium, or bottom? Bottom one. You're slightly bigger than 2. You plug into this function. So this would be equal to the limit as x approaches 2 from above of x minus 1 squared. And again, first rule of limits is plug in a number. This would be 2 minus 1 squared. That's 1 squared. Not ever you guys can see this. Which means it's equal to 1. So I ask you the question, what's the limit as x approaches 2 of f of x? Does not exist again. Why is the answer does not exist? Because the limit from below was 2, the limit from above was 1. They're not going towards the same thing. The limit doesn't exist. If this answer was 2 and this answer was 2, then I would say this answer would be 2. If this answer was 45 and this answer is 45, then the full limit would be 45. But if these two numbers are not equal to each other, as you do the limit from below and limit from above, then the answer is going to be does not exist. Does that make sense? Well, I'll give you guys a little background story. Most of you guys know that I graduated from NC State. That was my background. I got my undergrad, master's, and did a little bit of my PhD work at NC State. And as graduate students, we always, we're asked by any department that we work in, and we do the same thing here at UNC Charlotte. And that is, once we get a graduate student that has the magic 18 hours, so Katrina, when you get 18 hours of math in your graduate school, they're going to ask you to, would you like to work for the math department? And if you got the magic number 18 hours, you are qualified to teach a class. It's got to be a freshman, sophomore level class, but you're qualified to teach a class. So State said, would you like to teach a class, John? I said, yeah, I could use some money. And so I taught my first class. They handed me a calculus book and told me over in Harrelson where my class was at, and they patted me on the back and said, good luck, go explain it to them. And that's how I started teaching. Okay? Very little educational background. All I do is I know how to do math, and that's it. So, but luckily I'm a dude, so if I can do it, I can explain it to somebody else. So that's what I do. So, but I had a guy in my class. I'm going to pick on him. I'm going to pick on him until he dies. And even then, I'm going to continue to pick on him. I had a guy in my class. First test. And it was Calculus 1. So first test was on limits. And your first test will, guess what? Be on limits. And the test was on limits. And the entire test, for every answer on the test, the answer was 1. He put 1 for everything. And it took me the longest time to figure out why in the world he kept putting 1 on the test. And then it dawned on me one day, I just happened to look at his answers and my answers and stuff. Guys, that's a D for does not exist. I know it's my crappy handwriting, and I felt bad for the guy, but he like made a 2 on the test because there was like one answer that the answer really was 1. He got credit for that one. But the rest of them, he failed because he missed him because stuff like that. It's not an O, it's a D. And he just got confused with my D and E because he thought all the answers must be, I don't know what he was doing, but luckily he didn't, like, he dropped the class after a while. So, you know, there you go. But there you go. It's D and E for does not exist. It's not enough. Let's take a look at doing the visual perspective of a graph. We got a graph of a piecewise function. And we got some questions for you. So, you know, I stole these problems right off WebWork. So, you know, when we do these examples in class, I'm also trying to help you out with your WebWork problems here. All right, here's your g of x function. Comes up here, slaps here, then it breaks, and then we got a little discontinuity, and it comes up here. We got a nice little hole in the graph where there's the hole and there's the functional value, and it keeps on going. So we got some questions for you. Here's your coordinate axis, here's your y-axis, here's your x-axis. First question, what is g of 2? Here's 2 right there. What's g of 2? It's not a limit question, it's a functional value question. Where's the functional value at? Where's the dot at? And here, where's it at? The answer's 3. Next question, what is the limit as x approaches 2 from below? 2 from below. So limit as x approaches 2 from below. Okay, g of 2 there. 2 from below is right here. And from below, what functional value are you going towards? 3. However, what is the limit as x approaches 2 from the plus side, from the positive side, from above? From above 2, where's my functional value going? The y-coordinate is going towards 1. So I ask you the question. What is the limit as x approaches 2 of g of x? Does not exist. Because the limit from below doesn't equal the limit from above. Now, got another question for you. What's g of 5? Here's 5 right there. What's g of 5? Where there's the dot, there's where the and its y-coordinate is 1. What is the limit as x approaches 5 from below? 5 from below, so I'm going below. I come up here where the function's at, and what number is the function going towards? What y-coordinate is the function going towards? It's going towards 2. What is the limit as x approaches 5 from above? From above 5, from the positive side of 5, where is the functional value going towards? 2. So I ask you the question. What is the limit as x approaches 5 of g of x? The answer is 2. Because the limit from below is equal to the limit from above. It doesn't have a darn thing to do with what the functional value is. The limit from below and above are the same thing. That's your full limit answer. Does that make sense? All right. Well, you know there's got to be some interesting applications to this stuff, so it don't take us long to start getting into a little physics applications. And your first one is this, the concept of average velocity. To calculate average velocity, it is defined to be distance divided by time. That's what velocity is. Velocity is distance divided by time. To calculate, let's put this in your notes, average velocity, slightly different. This is delta distance divided by delta time. And I wrote that because I'm trying to get you guys into mathematical notation stuff. What does delta, the little triangle symbol, stand for? Change. So this is the change in distance over the change in time. So, if you want to write it as a formula, this will be S distance at time 2 minus distance at time 1 divided by change in time. Time 2 minus time 1. This is how you calculate average velocity. So here's a problem. A ball is thrown up, straight up, into the air with an initial velocity of 55 feet per second. Its height in feet, t seconds, is given by the equation y equals 75t minus 16t squared. Find the average velocity for the period beginning when time equals 2 and lasting 1.1 seconds. Now, this is WebWork the way they worded it. You got to think about a time interval. So if you start at 2 seconds and you last 0.1 seconds, you end at 2.1. So this is your time start, this is your time end, if you will. Time start, time end. So if we want to calculate the average velocity, your average velocity would be equal to y, which will be your distance at time 2, your ending time, which will be 2.1, minus y at your beginning time at 2, divided by the change in time, 2.1 minus 2. So now I'm going to use my handy dandy calculator here, and I'm going to plug in 2.1 into my function. That'll be 75 times 2.1, close parentheses there, minus 16 times 2.1 squared. And I get 86.94 officially feet. This would be the distance the ball has traveled in 2.1 seconds. Now I want to know what the distance, because I want to subtract it off, the distance the ball traveled exactly at 2 seconds. So this would be 75 times 2, plugging in 2 into my function, minus 16 times 2 squared. And I get 86 feet, divided by 2.1 minus 2. Let's do some arithmetic. What's 86.94 minus 86 is 0.94. Divided by 2.1 minus 2 is 0.1. And you don't need a calculator for this. What is 0.94 divided by 0.1? When you divide by 0.1, you move the decimal place one place to the right. And what do I get? 9.4. Let's go ahead and get you guys started out on the right foot. This is a physics problem. With a physics problem, we expect, if you're going to turn it in and write it up for us, we expect to have units on this stuff. What would my units be? What would be the velocity measured in? Very good. Feet per second. Now, honestly, on WebWork as a computer system, all they want is the number because that's what it's checking on. You don't type in units on WebWork. It'll throw a fit and tell everything's wrong because it can't read the units. But when you're doing tests and homework sets that you have to turn in, you got to throw your units on your work. Physics problems, okay? All right, next one. Find the average velocity starting at 2 seconds, but this time lasting 0.01 seconds. So if you start at 2 seconds, we start at 2 seconds and it lasts 0.01 seconds. That means that we end at t equals 2.01. So my interval now would be 2, 2.01. So pretty much what I'm interested in you guys is, what is the average velocity of the ball between 2 and 2.01 seconds? Between that margin. Does that make sense? So again, we need to calculate average velocity. This would be y of 2.01 minus y of 2 over 2.01 minus 2. Change in distance divided by change in time. So I need my calculator again. What is y of 2.01? Well, that would be 75 times 2.01 minus 16 times 2.01 squared. I'm plugging in 2.01 into my function, which was still way back up here. And what do I get? I get 86.1084 minus, what's y of 2? Well, that hasn't changed. When we plugged in 2 last time, what do we get? 86, so I'm sure it's still 86. Divided by 2.01 minus 2. So when I subtract 86.1084 minus 86, I get 0.1084. Divided by 2.01 minus 2 is 0.01. So here we go. Math without a calculator. It's impressive. What is 0.1084 divided by 0.01? Well, when I divide by 0.01, I'm going to move my decimal place 2 places to the right, and that gives me 10.84 what? Don't forget your units, feet per second. So the average velocity between 2 and 2.1 seconds was 9.4 feet per second. The average velocity between 2 and 2.01 seconds is 10.84 feet per second. Now here comes the last question on this thing. Okay, what is the average velocity for starting again at 2 seconds, but this time lasting 0.001 seconds. Okay? So again, if we start at 2 seconds and we last 2.001 seconds, this is my time at the beginning, so that would be like time 1. My time at the end would be what? 2.001 seconds. Does that make sense? And we want to find the average velocity between these two guys. So again, plugging into my formula, average velocity is equal to y of 2.001 minus y of 2 divided by 2.001 minus 2. So plugging in 2.001 into my function, 75 times 2.001 minus 16 times 2.001 squared, I end up getting 86.010984. No rounding on this stuff. Minus y of 2. When we did that one, we got 86 divided by 2.001 minus 2. So when I subtract, I end up getting, well, 86 minus 0.010984 minus 86 gives me the 0.010984 divided by 2.001 minus 2 is really divided by 0.001. And when you divide by 0.001, you're going to move the 3 decimal place 3 places to the right. What do I get this time? 10.984 feet per second. So the average velocity between 2 and 2.001 seconds, is 10.984. And I got one question down here. What is the instantaneous velocity? What is the velocity of the ball right at 2 seconds? Well, if you think about what you're doing in this problem, you are making the difference in the time go towards 0. So that would be the instantaneous, right at 2 seconds. What numbers am I approaching? 9.4, 10.84, 10.894. What number is this thing approaching? 11. The answer is 11 feet per second. And I have no idea where this thing showed up on your notes. So we just cleaned up the notes and all of a sudden we're finding another typo. We clean up typos and more typos pop up. So sorry, just get rid of that little spot down there. That's my first typo. Next semester, we'll clean it up for those guys. All right. Does that make sense? Did I lose you guys anywhere? Questions? Section 1.4. Section 1.4 is about calculating limits. So we've done elementary problems with you guys, and we're going to expand these problems into a little bit tougher problems. Okay? So first thing we got here in section 1.4 is the limit laws. The limit laws. So let me blow it up. You guys can see a little better in the back here. Okay? Assuming that f and g are functions and c is a constant, when you take the limit as x approaches a of f of x plus or minus g of x, that's equal to the limit as x approaches a of f of x plus the limit as x approaches a of g of x or minus the limit as x approaches a of g of x. Which means, when it comes to limits, when you're adding or subtracting, you can distribute the limit through each function and then analyze each function. Okay? Look at number 3. Property number 3 says when I take the limit as x approaches a of c times f of x, that's equal to c times the limit as x approaches a of f of x. Which tells me, what do I get to do with constants? I get to pull them out front, and I take that limit and go after where the function is at. Limits are not going to affect the constants. However, take a look at number 4. When you take a limit as x approaches a of f of x times g of x, you've got two functions and you're trying to find the limit as x approaches a of. When you multiply them, I can sit there and take the limit as x approaches a of the first function, multiply that times the limit as x approaches a of the second function, get your two answers, and then basically multiply together to get a full answer. Same idea with division. Limit as x approaches a of f of x divided by g of x is the same thing as taking the limit as x approaches a of f of x and divide it by the limit as x approaches a of g of x. This will always work provided the limit as x approaches a of g of x is not 0. Can't divide by 0, that's a problem. So as long as that denominator is not 0, you'll get the right answer. Number 6 is also important here. When I take the limit as x approaches a of f of x raised to the n power, there's my function, there's where the x is located at. This will be equal to the limit as x approaches a of f of x and then raised to the n power. In English, you take that limit and go after wherever the function part is located at. And if it's inside something to a power, you can put the limit inside that something to a power. If you go after where those x's are at. Okay? Property number 7. What's the limit as x approaches a of a constant? Well, first rule of limit is plug in a number, but if you got a constant, there's nothing to plug into. You just get the constant. Number 8. You take the limit as x approaches a of x. First rule of limit is plug in a number. X is a. What are you going to get? A. Take the limit as x approaches a of x to an n power. Well, first rule of limit is plug in a number. X is going to a, so that'll be a to the n power. Whether you have powers or radicals, same thing. Limit as x approaches a of the nth root of x. Well, plug in that x is a. That'll be the nth root of a. And because we're talking about radicals, I also have a very similar property that we had to property number 6 there, which was this. The limit as x approaches a of the nth root of f of x is the same thing as the nth root of the limit as x approaches a of f of x. When you got a function inside of a radical, you can pull that radical out and put that limit on the inside and keep doing your limit stuff. And then get your solution inside and then take the nth root of it for the final answer. So, let's take a look at these guys here. Now, how many of you guys, question, how many of you guys have actually watched the pre-section video of section 1.4 and taken the quiz before you came to class today? Thank you, you 5 people. Oh, you people are pathetic. Oh, I'm going to have a tough time with you guys. Katrina, slap them down. You understand? All right. You understand what I'm really going after here? I would like to have a class that everybody makes an A. I haven't had one yet. Okay. But I'm hoping you guys will be it. But you're starting off on the wrong foot, I'm afraid. You got to get this stuff done. Don't procrastinate. Procrastination kills your GPA and a few other things as well. So don't wait till the last minute. This is what you're expected to do before each class. Make sure before each class, because what I'm going to do is have those videos. They're going to cut off, and the quiz will drop on Canvas. The day that we start covering this material. And I know it's drop ad right now, so you got nothing to do. Yeah, that doesn't mean you don't have to do it, because I'm going to tell you right now, I know what's going to happen. When's drop ad over? What day? Tuesday. You know what's going to happen? Everybody's going to be scrambling Monday night to get everything done, because Tuesday, everything that was due this past week on the regular schedule is going to start closing out on you guys. Does that make sense? And then all of a sudden, you're going to miss out on the first 5 problems or something like that. So I'm saying, don't wait till the last minute. But when you do watch that awesome pre-section video, I did this problem for you guys. You'll notice that I labeled it with the word video here. And what I'm trying to do here is this. I'm trying to get you guys to watch the video, the pre-section videos in class. And since I typed up on the notes the exact same question that I did, I want you guys to kind of basically take notes off the video, so you've got a complete set of notes and stuff like that. So I did this problem and this problem on the video. So I'm going to pick it up down here. Okay? So here we go. Calculating limits. That's what we're all about with this stuff. The direct substitution property. If f is a polynomial or rational function and a is in the domain, then the limit as x approaches a of f of x is equal to f of a. This is right out of our textbook. But you know what this property is telling you? What's the first rule of limits? Plug it in. And that's exactly what they're doing. I'm just making the notation much nicer. First rule of limits, plug in a number. You want but the textbook doesn't say first rule of limits is plug in a number. They say the direct substitution property. If f is a polynomial or rational function and a is in the domain, then the limit as x approaches a of f of x equals f of a. Oh, that's great, but that's math notation here. In English, it means first rule of limits, plug in a number. If you get a number, you're done, because that means that a was part of the domain. So Take a look at these problems here. What is the limit as x approaches 5 of 2x plus 2 divided by x minus 3? First rule of limits is plug in the number. Now, to talk about properties, this is the same thing as doing the limit as x approaches 5 of 2x plus 2 divided by the limit as x approaches 5 of x minus 3. And honestly, I never write this type of thing except for you guys on the first time I do it. This is the limit property. Well, what's the first rule of limits? Plug it in. Well, I'm just going to plug it in. This will be 2 times 5 plus 2 divided by 5 minus 3. Well, I don't think I need a calculator for this. 2 times 5 is what? 10 plus plus 2 is 12. Divided by 5 minus 3 is 2. And 12 divided by 2 is 6. The answer is 6. Does that make sense? First rule of limits, plug a number. Well, that's no problem. Yeah, watch this one. This is one that people start crying over. What's the limit as theta approaches pi of the cosine of theta? What's the first rule of limits? Plug it in. So what's this equal to? The cosine of pi. Well, right here, people got that part. It's what's the next is what kills them. What is the cosine of pi? I hear like 4 different answers. Okay. That's math. There's only one answer. Which one is it? Cosine of pi. Pi is equivalent to 180 degrees. It's over there on the other side. Think about your unit circle stuff from high school. It's not 0. It's the other dude. -1. Thank you for that one person that knew it. Yay. Okay. -1. The cosine of pi is -1. Well, geez, Dr. Taylor, yeah, I could have got that. I'm in radian mode on my calculator. Oh, yeah, there we go. I go cosine of pi. There's the old pi button. And what's the answer? That's still -1. Problem with that is, did I mention about the final exam and about the no calculator section on the final exam? And this is the kind of problem they're going to put on the no calculator section on the final exam. They expect you to know that trig stuff because it's a prerequisite for graduating high school. So you have to know it before you ever get to a calculus class. Just to let you know. All right. Another property here, the indeterminate form. If the limit as x approaches a of f of x equals f of a, which is equal to the 0 over 0, which means first row limits plug it in, and you get 0 over 0, then factor, simplify, or multiply by conjugate. You know what that is in John's world? Do algebra. You got it. They're just telling you what kind of algebra you possibly can do. You can factor, simplify, multiply by conjugate. Don't worry about that last one in a second. So here's the rule. Let's take a look at these problems. Take the limit as x approaches 4 of x squared minus 16 over x minus 4. First rule of limits is plug it in. So this would have been 4 squared minus 16 over 4 minus 4. 4 squared is 16 minus 16 is 0. 4 minus 4 is 0. So I get to do algebra. Limit as x approaches 4 of, well, again, with 0 over 0, you're trying to factor so you can get something to cancel here. X squared minus 16 factors into x plus 4 times x minus 4 from a difference of squares, divided by x minus 4. The x minus 4's cancel. So this is equal to the limit as x approaches 4 of the resultant, which is x plus 4. Okay? And then, once you clean it up, you start the limit process over again. What's the first rule of limits? Plug it in. This will be 4 plus 4. Answer's 8. Does that make sense? But remember, it's not just about getting the right answer. You've got to show the work in getting the right answer. When I plug in the number, I don't write limit, and I check it, 0 over 0, which means I'm going to do algebra. So this would be equal to, and then I write limit, and then I do algebra on that x squared minus 16 over x minus 4. I factor x plus 4 over x minus 4. X plus 4 times x minus 4 divided by x minus 4. I canceled it, and before I plug in the number, I'm going to write limit again. Limit as x approaches 4 of the resultant, x plus 4. And then, once I plug in the number, I don't write limit anymore, and then I show you my solution. Because I remember, no work means no credit. Okay? So this is the work way we expect to see. So the next one. Take the limit as x approaches 0 of x plus 2 squared minus 4 over 2x. All right? First rule of limits. Plug in a number. So I'm going to plug in 0. This will be 0 plus 2 squared minus 4 over 2 times 0. All right, 0 plus 2, I can handle that kind of math. That's like 2. Squared is 4. Minus 4 is 0 over 2 times 0 is 0. What a surprise. 0 over 0, which means I'm going to do algebra. My question to you is very simply this. What algebra would you do on this problem? X plus 2 squared minus 4 over 2x. Well, personally, the first thing I'd do is I would clean it up. X plus 2 squared, I would clean this up by folding it out, right? So that's the same thing as x plus 2 times x plus 2, x plus 2 squared, minus 4 over 2x. And I wrote it that way for your benefit, but I would fold this thing out. X times x is x squared. That's equal to the limit as x approaches 0 of x squared plus 2x plus another 2x makes it plus 4x. 2 times 2 is plus 4 minus 4 over 2x. What ends up canceling after you fold that thing out? The plus 4 minus 4 cancels, so this is equal to the limit as x approaches 0 of x squared plus 4x over 2x. Then what would you do? Remember, the goal is to cancel. Nothing is canceled yet. Numerator, denominator, yeah, plus 4 minus 4, who cares? But this numerator, denominator, you're trying to cancel. What can you get to do now? Well, what do you have in common in that numerator? Well, what I have in common is an x, the x squared and the 4x, right? So I can factor an x out. So this is equal to the limit as x approaches 0 of x times x plus 4 divided by 2x. And through strict multiplication division, things cancel. The x is canceled here. So this will be equal to the limit as x approaches 0 of the resultant x plus 4 divided by 2. Notice how I wrote limit, 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 limit every time I'm doing the algebra until I've cleaned it up. And then I got the limit as x approaches 0 of x plus 4 divided by 2. What am I going to do? Plug it in. And when I plug it in, I don't write limit anymore. That'll be 0 plus 4 divided by 2. That's 4 divided by 2, which is 2. Answer's 2. Does that make sense? Questions? Take a look at the next guy. I want you to take the limit as x approaches 0 of the square root of x plus 16 minus 4 divided by x. First order limits, plug it in. That'll be the square root of 0 plus 16 minus 4 over 0. 0 plus 16 is 16. Square root of 16 is 4. Minus 4 is 0 divided by 0. So first thing I want to do is, before I do any algebra on this thing, I want to make sure it's the 0 over 0 case, the indeterminate case. Now, it's 0 over 0, so I'm going to do algebra. Here's my problem. The limit as x approaches 0 of the square root of x plus 16 minus 4 divided by x. What kind of algebra would you do? Well, you can't factor anything out. But what should be reminding you of things is it's a square root. And when you got the square root of something plus or minus something or other, the way to clean that kind of guy up is something called conjugates. This is where that conjugate thing comes in. It's with the radicals, especially the square roots. So to clean this guy up, it's a special kind of algebra. We're going to use conjugates. What I do to the numerator, I have to do to the denominator. What is the conjugate of the square root part? What's the conjugate of the square root of x plus 16 minus 4? It's the square root of x plus 16 plus 4. It's the exact same thing except you change the sign in the middle. However, what you have to do based upon algebra is to manipulate this guy. I want to multiply the radical by its conjugate. The square root of x plus 16 minus 4 by its conjugate. But whatever I do to the numerator, I have got to do to the denominator, which makes it a ratio of 1, which doesn't change the problem. Does that make sense? And listen to my words. If you're going to do the conjugate trick to a particular problem, you want to FOIL out conjugate pairs. You want to leave factored non-conjugate pairs because the ultimate goal is still to cancel. So keep it factored. Don't try to distribute through. It just messes up your work. Keep things factored, but multiply, FOIL out conjugate pairs. So these are my conjugate pairs. I'm going to multiply this out. So this is equal to the limit as x approaches 0 of. Here we go. What is the square root of x plus 16 times the square root of x plus 16? X plus 16. The square and the square root cancel itself out. The outer, the square root of x plus 16 times plus 4 will be plus 4 square root of x plus 16. Just slap them together. The inner, minus 4 times the square root of x plus 16 would be minus 4 square root of x plus 16. And then last, what is minus 4 times a positive 4? Minus 16. Divided by non-conjugate pair stuff, leave factor x times parentheses, square root of x plus 16 plus 4. Does that make sense? Did I lose you guys anywhere? Questions? All right. Here we go. What cleans up? Well, first off, anytime you guys full out conjugate pairs, the outer inner will always cancel. That 4 square root of x plus 16 and the minus 4 square root of x plus 16 will always cancel when you full out conjugate pairs. But in this case, what else cancels? The 16s cancel. That leaves you with the limit as x approaches 0 of x on top divided by x times the square root of x plus 16 plus 4. And because you left this factor to strict multiplication division, what cancels? The x's cancel. So this would be equal to the limit as x approaches 0 of 1 over the square root of x plus 16 plus 4. And now, to evaluate this thing, once you clean it up and do the canceling on that 0 divided by 0, what am I going to do? Plug it in. This will be 1 over the square root of 0 plus 16 plus 4 in the denominator. That's 1 over 0 plus 16 is 16. Square root of 16 is 4 plus 4. What's my answer? 1/8. There's my solution. So you want to factor and cancel something or other, but on some of these special problems, don't forget the famous conjugate trick on with radicals. So that's a special trick that only works with the square root plus or minus something or other there. Okay? All right, we're in section 1.3. There are 3 cases to limits. This is real important because I'm breaking it down for you guys. 3 cases of limits. First case, plug in a number, get a number, you're done. Second case, plug in a number, get 0 divided by 0, then you are supposed to, quote unquote, do algebra if possible. Cancel something out and then redo the limit. Okay? If you cannot do the algebra, you've got no choice. You're going to have to do the t-bar and take the limit from as x approaches a from below, limit as x approaches a from above, and show me the work through the t-bar. Okay? Remember the sine of x over x example there. Okay? Third case, the undefined form. If the limit as x approaches a of f of x equals f of a is equal to a number divided by 0, then the limit does not exist, D and E. You can support your answer by doing the graphing table below to show your work. You can do the table or put the graph in it, but here's the deal. This is important. This is not 0 divided by 0. This is some other number divided by 0. And what are you not allowed to divide by? 0. So the answer is automatically, when you plug in a number and you get a number divided by 0, the answer in section 1.3, this does not exist. When we get you guys into section 1.6, we're going to go back and look at this thing, and then we're going to go after the infinite limits. The limit as x approaches a number and it blows up or blows down. If it blows up, we'll call it infinity. If it blows down, we'll call it negative infinity. So we're not done with this particular type right now. But in chapter 1.3, real simple. First rule of limits, plug it in. If you get a number divided by 0, declare victory. The answer is going to be D and E. Does not exist. So here's an example. What is the limit as x approaches 5 of x squared minus x minus 6 divided by x minus 5? First rule of limits, plug it in. Let's see here. 5 squared minus 5 minus 6 divided by 5 minus 5. 5 squared, 25. Minus 5, 20. Minus 6, 14. Divided by 5 minus 5, 0. What do I got? Number divided by 0. So the answer is does not exist. Done. Does that make sense? But I'm warning you, this is too easy. Wait, we're going to go back to section 1.6 and we're going to analyze this from a what's really going on perspective. But right now, we're just worried about your algebra skills. You can't divide by zero. That does not exist, and that's really what we're saying here. Okay? As I mentioned to you before, and now it's a theorem, it's posted on your notes here, we say that a limit exists when the limit from the left is equal to the limit from the right. In other words, the limit as x approaches a of f of x equals L, if and only if, that's what the double arrow symbol stands for, if and only if the limit from as x approaches a from below of f of x equals L equals the limit as x approaches a from the right of f of x. In other words, a full limit exists as long as you have this. The limit from below is equal to the limit from above. You got to be going towards the same y coordinates. That just written down in theorem format. Okay? So, and again, I did this particular problem on your pre-section video on section 1.4. So I try to put them in, on the video examples that I did on the pre-section video, I put them where they kind of placed in our notes. So they're not all right there at the beginning. Sometimes I kind of talk about some brother that I'm going to come back to and stuff. And here's another one right there. So I'll put video by it so you'll know that it was on the video. So I'm going to do this problem right here. Okay, since I did this one on the video. Here we go. H of x is equal to x squared if x does not equal 2, and negative 1 if x equals 2. My question to you is this. What is the limit as x approaches 2 from below of h of x? What is the limit as x approaches 2 from above of h of x? And what is the limit as x approaches 2 of h of x? Well, here we go. Take the limit as x approaches 2 from below. From below means I'm slightly less than 2. This is a piecewise function. If you are x's are slightly less than 2, you're not equal to 2. So which piece of the piecewise function do I get to use if I'm not quite equal to 2, but I'm a slightly less than 2? Top or bottom? Top. So this would be equal to the limit as x approaches 2 from below of x squared. Right? But regardless if it's a one-sided limit or a full limit, whatever, once you figure out the functional part, what's the first rule of limits you're going to do? Plug it in. So this would be 2, visually from below, squared. Fine. What's 2 squared? 4. If you get a number, you're done. That's just 4. Now, what is the limit as x approaches 2 from the plus side or the right side of 2? Okay? Of h of x. Well, which piece of my piecewise function do I get to use? Top or bottom? Top, because I'm not quite equal to 2. I am slightly bigger than 2. Bigger than 2 means I'm not equal to 2. I use x squared. So this would be the limit as x approaches 2 from the plus side of x squared. This would be 2 on the plus side squared. 2 squared is 4. So I ask you the question. What is the limit as h approaches 2 of h of x? The answer is 4. Why? Because the limit from below was going to 4. The limit from above is going to 4. They're going to the same number. But, I got another question for you. What is h of 2 equal to? I want you to see the difference between the limit and the functional value. What is h of 2? That's when x equals x equals 2, which means the answer is negative 1. Okay? There you go. Well, we got a couple more examples to do next time. And the next time we're going to talk about something called the squeeze theorem. But don't forget, we have our review session. We'll start our first review session tomorrow, Friday, and it's at 3:30 in Fretwell 121. And you'll see both my preceptors being in charge over there, so you'll get to know your preceptor even better, Katrina. So see you guys then. Take care.
No.